Okay, and here's another example that is much trickier because these are just not familiar functions. So we're going to use our calculator here, and fortunately I have each of these functions plugged in. So when I look at the graph, well, there it is. There's the region we're looking for. We need our limits of integration. It sure looks like one point of intersection is at 0, and we could test that by plugging 0 in for x, and sure enough y is 0. We need to find this one though, so let's do second calc, and we're going to do number 5. And that's on my first curve, pretty close to the point of intersection, so I'll press enter. Second curve, good enough, press enter. Guess, always just press enter. Okay, so here's my point of intersection. So I need to remember this x value, which is one pain in the neck because I don't feel like writing it down. So what I'm going to do is just store that. So I'm going to just check that in my x is that number, which it is, that looks familiar, and then I'm going to store that under A. Okay, so now I'm ready to go. So I have my top function minus my bottom function. I'm just going to do the old math 9. My limits of integration, I start at 0, and then I'm going to use A, and then my top function is y sub 1, so I'm going to do vars, y vars function y sub 1 minus vars, y vars, function y sub 2, and we're integrating that with regard to x, so we'll just press enter, and there's the area between these two functions. Okay, so let's do another one. So for something like this, now notice how tricky this is, because over here my purple function, my f of x, is on the top, whereas over here it's on the bottom. So this is a situation where you just have to split these up a little bit. And here's another kind of weavy through one. So let's just do this one. So for the first part, for a sub 1, let's, for a sub 1, we need to take the antiderivative between 0 and pi over 4. Of top minus bottom is going to be cosine minus sine. Dx. And for the rest, I'm going between pi over 4 and pi over 2. And I'm going to do sine of x minus cosine of x dx. So this is going to give me the pink region, this is the blue region, and then I'm just going to add them together. But something else that you might notice, they sure look like they're the same shape. And in fact, they are. So if I found this region, I could just multiply it by 2 to get the total shaded region. So let's just do that. So the antiderivative of cosine we know is sine x. The antiderivative of negative sine is cosine of x. We're looking at this between 0 and pi over 4. So if we plug in pi over 4, for sine I get 1 over root 2. For cosine I get 1 over root 2. From that I'm going to subtract. Sine of 0 is 0, cosine of 0 is 1. So this just gives me 2 over root 2 minus 1, or 2 root 2 over 2 minus 1, or just root 2 minus 1. Now, that's just this area, root 2 minus 1. Would also find this has the same area, so the total shaded area is 2 root 2 minus 2. And that's not terrible. Okay, so now let's just practice. This is the worksheet that you're going to do in class. And if I was going to slice this into rectangles, let's slice it. And it sure looks like every single rectangle has as its width delta x, and every single height is this big change in y. So it's defined by my y here minus my y here. So I'm just going to write the antiderivative. It looks like we're going between 0 and pi. My top minus my bottom is 1 minus cosine squared of x dx. And that's going to take all those x values between 0 and pi and nothing else. If we look at number 2, kind of same situation. I'm going to slice this. I kind of like to draw the rectangles in. So here's a sample rectangle, and it doesn't matter where I pick it. my delta x is going to be the width, and my height is the y here minus the y down here. Y defined by this function minus the y defined by the bottom function. So we're going between negative pi over 3 and pi over 3. Our top function is 1/2 sec squared of t. Our bottom function is minus 4, so that's going to become plus 4 sine squared of t dt. And if I was feeling kind of lazy, I could also use symmetry. So I could also do 2 times the antiderivative between 0 and pi over 3 of that whole thing. And that would be fine. Number 3, okay, a little bit of a pain in the neck, so let's examine this a little bit. I'm going to slice like this, and each of my rectangles is defined on top by this, on the bottom by this. My thickness is dx, so I know I'm integrating with regard to 0 and 1. Each is dx, and the only thing that's a pain in the neck here is that these are kind of defined in a funny way. So I really need my y here written as a function of x. So the y at the top really should be the cube root of x. Over here, I really should be saying y equals the square root of x. So we have x to the 1/3 minus x to the 1/2 dx. And let's just do this. Antiderivative of x to the 1/3 is 3/4, x to the 4/3. Antiderivative of x to the 1/2 is 2/3, x to the 3/2. And we're looking at that between 0 and 1, which ends up just being 3/4 minus 2/3, which is just 9 minus 8, 1/12. Okay, now here's another thing we could have done. I'm just going to play with this a little bit, and what I'm going to do is erase this and erase all of this, and I, in fact, am going to slice it a little bit differently. So another thing that I could do if I felt like it is slicing it in this direction, in which case, notice what happens. This is a sample rectangle, and my thickness is dy. It's a movement in that vertical direction. The length of each rectangle is, well, it's a movement in this direction, so that's a big delta x. So I need my x here minus my x here. Well, my x here for every one of these rectangles is defined by y squared. So I'm going to take my furthest right minus my left and integrate with regard to y, and my limits for y value are, it goes from 0 to 1. Now let's do this. This is y squared minus y cubed, so the antiderivative of y squared is 1/3 y cubed. The antiderivative of y to the 4th is 1/4 y to the 4th. We're looking at that between 0 and 1, and if we plug a 1 in, we get 1/3 minus 1/4. If we plug in a 0, we just get 0, so once again, that's going to give us 1/12. Same answer. Okay, and I'm going to stop right now and let you catch up.